Beneath the waves lives a family of creatures so intelligent, so dazzling, and so utterly otherworldly. These are the cephalopods. A class of mollusks so highly developed, they've been called the wizards of the deep. This family includes the ingenious octopus, the swift squid, the artistic cuttlefish, and the living fossil, the nautilus. Their dance is one of grace and lightning-fast change. Their minds are complex puzzles, and they are, without a doubt, some of the ocean's most important and peculiar inhabitants. They are masters of every marine realm, from sundapple kelp forests to the eternal midnight of the abyss, from bustling coral cities to lonely rocky shores, and their size range is almost unbelievable. One member, the giant squid, stretches longer than a school bus, a true phantom of the deep. Yet another is so tiny, it could comfortably perch on your fingertip. So, what exactly makes a cephalopod? Let's break down their blueprints. They are, simply put, the most advanced mollusks on the planet. While their snail and clam cousins lead slow, simple lives, cephalopods evolved into agile, brainy predators. Their story is an ancient one. Fossil whispers tell us they've been navigating Earth's oceans for over 500 million years. Cephalopod means head-foot, and that's precisely what they are, a head fused seamlessly to a crown of living limbs. Every model shares a core design, a pair of large camera-like eyes, a muscular cloak called a mantle, a jet propulsion funnel, and right in the center, a ring of arms, hiding a mouth equipped with a beak as sharp and powerful as a parrot's. And it's these arms that forge their legendary reputation. Take the octopus. Its 8 arms are lined with hundreds of sensitive suckers, but these are far more than sticky cups. Each one can move independently, can taste what it touches, and can feel its way through a maze as deftly as a hand. To understand the octopus of today, we have to meet its ancestor, a small snail-like creature tucked safely inside a hard coiled shell, crawls cautiously along the ancient seafloor. But around 140 million years ago, something revolutionary happened. One bold branch of this family tree ditched the shell. By shedding that bony armor, they traded protection for something more powerful: total fluid freedom. With almost no hard parts, save for one sharp beak, the octopus became a master of contortion. If its eyeball can fit through a crack, its entire body can follow. This is the ultimate escape act, perfect for slipping away from hungry sharks or dolphins. But going soft and squishy made them vulnerable, so evolution crafted a defense system far more clever than any shell: the art of becoming invisible. Meet the octopus's secret weapon: chromatophores. Think of them like living pixels speckled across its skin. Each one is a tiny elastic sac filled with pigment, a miniature balloon of black, red, or yellow dye. By flexing its muscles to open and close microscopic color sacs at mind-blowing speed, the octopus can paint living patterns across its body: bands, stripes, and spots. In a heartbeat, it can become a lump of coral, a patch of seaweed, or a shadowy rock. Beneath the chromatophores lies a layer of magic mirrors. the iridophores. These are stacks of impossibly thin cells coated with a reflective protein. They don't make color, they catch and bounce back the ambient light, creating shimmering metallic blues, greens, and silvers. And beneath that, a third layer, the leucophores, act like a living projection screen, scattering white light to brighten the overall effect. By mixing its pigment paints with these reflective mirrors and screens, the octopus can match almost any background with photorealistic accuracy. But it has one final genius trick, using structures called papillae. It can change the very texture of its skin. It can raise bumps, create spines, or become perfectly smooth. This 3D disguise breaks up its outline completely. Many predators hunt by looking for a clear, recognizable shape against the background. The octopus doesn't just change color, it dismantles its own silhouette. Without a shell, the octopus became soft. But with this layered toolkit of color, light, and shape, it learned to become a ghost. For millions of years, in an ocean full of eyes, it has perfected the art of not being seen. But a perfect disguise is useless if you can't apply it in an instant. For the octopus, survival hasn't just hinged on having camouflage. It hinges on the breathtaking speed and intelligence with which they control it. Imagine walking through a constantly shifting landscape, having to change your entire outfit, your color, your pattern, even your texture, with every single step. That's the octopus's reality. It's a live, high-stakes decision-making marathon. One researcher clocked an octopus changing its disguise 177 times in a single hour. Its reaction time is the fastest in the animal kingdom. In less than 200 milliseconds, faster than you can blink, its skin can tell a whole new story. So, how is this possible? The answer lies in a mind that's organized unlike anything we know. The octopus has a formidable nervous system, large like ours, but wired according to a completely different blueprint. The common octopus possesses roughly 500 million neurons. To put that in perspective, humans have about 100 billion. But here's the truly alien part. Of those 500 million neurons, only about 1/3 are in its central brain. The overwhelming majority, the other 2/3, are distributed throughout its 8 arms. This means something extraordinary. Each arm has a kind of mind of its own. It can taste, touch, and make basic decisions independently. In a very real sense, an octopus doesn't just use its arms, it thinks with them. This decentralized intelligence allows for split-second, localized camouflage changes without the central brain having to micromanage every single pixel. It's a distributed computing network with arms that can react to their immediate environment on the fly. And sometimes, the smartest trick isn't hiding in the background. It's pretending to be something else entirely. Observe the flounder trick. When crossing open ground, an octopus will often compress its body, pale its skin, and adopt a stiff, side-to-side swimming gait. It is, convincingly, imitating a flatfish. This isn't just camouflage, it's active mimicry. By impersonating a flounder, a creature that is itself unpalatable or uninteresting to many larger predators, the octopus buys a pass. It's a brilliant behavioral layer on top of its physical disguise. Why just hide when you can also bluff? Like the octopus, many squid possess 8 arms, but evolution has given them an extra pair of tools for the hunt. Meet the tentacles. 2 specialized elastic harpoons. They can launch with bullet speed to snatch prey from a distance, then reel it back to a waiting beak. It's a long-range fishing system built right into their bodies. But appendages are just the beginning. To thrive in the vast, often lightless expanse of the open ocean, cephalopods have evolved one of nature's most magical survival tools. In the endless midnight of the deep, they carry their own suns. This is bioluminescence, the living light. For squid, it's not just a glow, it's a language, a lure, and a cloak of invisibility, all written in flashes of blue and green. A single flash can say, "Back off." A rhythmic pulse can whisper, "Over here." A gentle glow can trick a curious shrimp into becoming a meal. Take the firefly squid, a creature that turns the sea into a starry sky. Its secret is a chemical called luciferin. When luciferin meets oxygen inside special light organs, it ignites like a cold biological spark. And the squid has exquisite control over this chemistry, able to dial the brightness up or down with neural precision. This control unlocks a survival superpower called counter-illumination. Here's the genius. When viewed from below, a squid is silhouetted against the faint glow from the surface, a clear target. But by producing a gentle matching glow on its underside, it erases its own shadow. To a predator looking up, the squid simply disappears into the background light of the sky above. It's active camouflage, using bioluminescence to paint itself out of existence. Cephalopods don't just use their color-changing powers to vanish. They also use them to speak, to boast, and to dazzle. The cuttlefish engages in courtship displays so intricate and vivid, they rival the most colorful birds of paradise. Don't let the name fool you. Cuttlefish are neither cuddly nor, technically, fish. They are cephalopods, close cousins to squid and octopus. You'll find them in shallow coastal waters around the world, from European seas to Asian reefs, dancing over seagrass beds and coral. With about 120 known species, they come in a spectacular range of sizes. The palm-sized flamboyant cuttlefish could fit in your hand, while the giant Australian cuttlefish can grow longer than your arm and weigh as much as a large bag of groceries. Their name is a bit of a historical mystery, coming from an Old English word whose meaning is lost. Throughout history, we've been entranced by them, calling them inkfish, sea cat, or sepia, the latter from the ancient Greeks and Romans who prized their rich, dark ink for writing and dyeing cloth. But maybe we struggle to name them perfectly because they are simply so wonderfully strange. Take the simple act of floating. For a fish, it's a gas-filled swim bladder. For a whale, it's thick blubber. But for the cuttlefish, evolution crafted a masterpiece of natural engineering. The cuttle bone. This isn't a bone like ours. It's a lightweight, porous internal shell. The magic is in its design. It's both incredibly stiff and full of tiny chambers. These two traits usually work against each other in nature, but the cuttlebone balances them perfectly. A hard, dense layer on top acts as armor. Beneath it, a delicate matrix of microscopic chambers, each one a tiny buoyancy tank. Here's how it works. The cuttlefish can precisely control the ratio of gas to fluid inside these chambers. Need to rise? Pump fluid out. Let gas fill the space, and up you float. Need to sink? Let fluid in, and down you go. It's a built-in adjustable submarine ballast tank. This gives them a huge advantage. Unlike the constantly swimming squid or the bottom-crawling octopus, a cuttlefish can achieve neutral buoyancy, hovering effortlessly in mid-water with minimal effort. But this ingenious structure has a limit. While it can handle the pressure of shallow seas, the crushing weight of the true deep ocean would implode its delicate chambers. The cuttlefish is a master of the sunlit shallows, forever barred from the abyssal depths by the very bone that gives it grace. But in the world of cephalopods, there's always an exception that proves the rule. Meet the tiny artists, the flamboyant cuttlefish and the paint pot cuttlefish. These miniature marvels, barely the length of your finger, have a problem. Their cuttlebone is so small, it can't act as an effective ballast tank. Hovering like their larger cousins isn't an option. So, they've evolved a different strategy. They walk. Using their arms and fins like little stilts, they amble across the seafloor. Moving slowly, they become just another part of the sandy landscape, the perfect ambush predator for unsuspecting shrimp and small fish. But when this gentle camouflage fails, they have a backup plan that is anything but subtle. They switch from master of disguise to flamboyant performer. Their skin blazes with warning colors, vivid yellows outlined in black, paired with hypnotic rolling waves of pattern. This is no attempt to hide. It's a bold, shocking statement. I am toxic, or dangerous, or not worth the trouble. It's a dazzling bluff that often makes a predator think twice. Yet, for all their flashy warnings, their true genius is still in vanishing. And they perform this magic on the ultimate stage, the coral reef. A reef is a visual chaos of color, shape, and shadow, one of the most complex scenes on the planet. And yet, a cuttlefish can become a piece of it in an instant. It doesn't just match color, it matches in 3 dimensions. Beneath its color-changing cells, it has a layer of tiny muscular pixels called dermal papillae. By flexing these, it can physically reshape its skin into bumps, spikes, or ridges, mimicking the rough surface of coral, the slickness of a rock, or the fuzz of algae. This creates a complete 3D disguise that is almost impossible to detect. But here lies one of the greatest mysteries in all of animal cognition. Remarkably, despite this flawless color matching, cuttlefish, like most of their cephalopod family, are technically colorblind. Their eyes have only one type of light-sensitive protein, meaning they see the world in shades of gray. They perceive brightness in contrast with incredible precision, but not color as we know it. So, how does an animal that sees in black and white perfectly replicate a world exploding with color? Scientists are still piecing this puzzle together. Some think their uniquely shaped pupils may act like prisms, breaking light in a way we don't yet understand. Others believe their skin itself might see and react to light independently of the brain. For now, it remains one of the ocean's most captivating secrets, a silent, living proof that there are wonders in the deep that defy our simplest explanations. From the colorful shallows, we now voyage into deeper time and deeper water to meet cephalopods that seem to break all the rules. First, a living relic, the nautilus. It is the last of its kind, the only surviving cephalopod that never abandoned its external shell. This spiraled home is a direct link to an ancient era over 200 million years ago, when shelled cephalopods, the ammonites, were the undisputed rulers of the seas. In the deep, A strange rule often applies: deep-sea gigantism. In the cold, sparse, dark waters, some creatures grow to monstrous sizes. This phenomenon fueled centuries of sailor legends, like the terrifying Kraken. And as it turns out, the legends were rooted in truth. Meet the Magna Pinna, or big fin squid. This ghostly phantom, glimpsed only by deep-diving robots, defies everything we know. Its arms and tentacles are all the same extraordinary length, held at right angles like a creature from another planet. Estimates suggest its slender filaments can stretch over 20 times the length of its body, making it one of the most alien-looking animals ever recorded. Gigantism takes other forms, too. The fearsome Humboldt squid, a pack hunter in the Twilight Zone. The legendary giant squid, a bus-length leviathan, and the true heavyweight champion, the colossal squid, armed with hooks and swiveling claws. In a world where food is scarce, bigger size means greater efficiency and dominance. This incredible diversity isn't just for show. Cephalopods are linchpins of the ocean's food web. Their intelligence makes them cunning, adaptable predators. Their toolkit is brutal and efficient. A sharp parrot-like beak that can slice through flesh and shell, and a tongue-like radula lined with microscopic teeth that can drill and scrape. But their soft bodies make them the ultimate prize. They are vital fuel for sharks, tunas, dolphins, and most famously, the deep-diving sperm whale, which ventures into the abyss to battle the giant squid in one of nature's most epic rivalries. So, what are we to make of the cephalopods? They are the masters of light and shadow, painting with their own skin. They are architects, engineers, and illusionists. They are living fossils and deep-sea giants. Their intelligence is unparalleled in the world of invertebrates, a testament to evolution's creativity in crafting a mind that is both centralized and spread through 8 wandering, curious arms. The deep sea remains the greatest unexplored frontier on our planet. If it has already given us beings this astonishing, one has to wonder, what other wonders await in the dark, just beyond the edge of our light?